In this lesson, I'd like to talk about the gas combustion process. Combustion is the burning of a substance. It's also known as rapid oxidization because that's exactly what's going on. We're rapidly combining oxygen with a substance, adding some heat, and causing combustion. All matter is made of elements. One of the most basic elements on Earth is oxygen. Many materials react with oxygen. This is a process called oxidization. Rusting a metal is a common form of this process. Sometimes heat must be added for this process to take place, and sometimes heat is given off from the oxidization process. When oxygen acts with a substance to produce large amounts of heat rapidly, and usually light as well, the process is called combustion or burning. With enough air present, fuel gases will burn in their normal gaseous state. Solid or liquid fuels, on the other hand, must be changed to a gas first before they will burn. Usually heat is required to make this transaction of solids to gas or liquids to gas. Solids will not burn. In order for this combustion to take place, three things must be available: fuel, oxygen, and heat. Take away any one of these and the burning process will stop. Let's use a wood-burning fire as an example. Throw a blanket over the fire and cut off the air. The fire will go out. Drag all the wood away from the fire and the fire goes out. Throw water on a fire, chill the wood temperature, and the fire will go out. The same requirements are needed for a gas fire. The heat for ignition must be provided by an outside source. The outside source must raise the temperature of the gas to about 1100 to 1200 degrees. Gas alone by itself will not burn. You must also have air to supply the oxygen. An open flame or a pilot or an electronic means of heat may be used to ignite the gas. Once ignited, the gas flame itself will provide the heat needed to sustain future combustion. Combustion of a gas is a reaction between fuel gas and oxygen. The gas contains hydrogen and carbon. When hydrogen burns, water vapor is produced. The water molecule now consists of 2 hydrogen atoms and 1 oxygen atom. Complete burning of the gas forms carbon dioxide, or CO2. The water vapor and the carbon dioxide formed by that burning process are called products of combustion. There are 3 types of combustion that we need to talk about. First is controlled combustion, second is incomplete combustion, and the third is explosive combustion. Controlled combustion takes place when fuel gases and air are supplied at proper rates to assure a complete burning of the gas in a steady flame. When a gas appliance is burning properly, the burning starts at the burner port. Gas flow rates are controlled by the gas orifice size and the gas pressure upstream from the orifice. Burners which have some air pre-mixed with the gas before it passes through the burner ports are called blue flame burners. The air is added to the gas is called primary air. The rest of the air required for complete combustion is supplied to the burner flames in the combustion chamber, and it is called secondary air. Yellow flame burners only use secondary air. They do not have any primary air mixed in. Adjustments to the gas rates and primary air is the key to obtaining stable blue flames on a burner. Air shutters or other devices may provide the control of the primary air. This is an example of a blue flame burner. We take our gas, we mix it with air in the venturi, and that is primary air. The secondary air gets mixed in around the burner through whatever imports are available in the furnace itself. There's a gas-air mixture that's coming out of the burner ports. A good gas flame is sitting right on top of the burner port, very dark blue center, light blue, and then slight orange tips. Proper amounts of primary air and secondary air are needed for quiet and efficient appliance operation and the complete combustion of gas. The size of the air inlet openings and the flue outlets control the secondary air. So we take our fuel, which is hydrocarbon, hydrogen, carbon, top left. We mix it with oxygen out of the air, and we have the nitrogen as well, which is a large proportion, almost 79% of air. We take it through the combustion process, which is rapid oxidization. Our output, or our products of combustion, are carbon dioxide, water vapor, and nitrogen. Controlled combustion requires the specific amounts of air. We take natural gas. It requires 15 cubic feet of air for each cubic foot of gas. Propane requires 23.5 cubic feet of air for each cubic foot of gas, and butane requires 30 cubic feet of air for each cubic foot of gas. Incomplete combustion is caused by a lack of this air. If not enough air is present, or it is not mixed with fuel, complete combustion does not take place. When combustion is not complete, the products of combustion change. Harmful chemicals such as carbon monoxide can be produced. Poor venting, which restricts airflow, will cause a lack of oxygen. The poor airflow will also allow the products of combustion to spill into the room. Products of incomplete combustion that could spill into the room is carbon monoxide, which is a toxic gas that can cause death if enough is inhaled. CO has no odor, taste, or color. Inhaled, CO is absorbed into the blood and reduces the ability for the blood to absorb oxygen. Too much carbon monoxide in the blood can cause the person to die from a lack of oxygen. Before dying, the person will feel tired and may fall asleep without knowing they are being suffocated. CO has now been associated with Alzheimer's and attention deficit disorder. Incomplete combustion, you will see lazy yellow flames showing some yellow color. There's not enough air to support combustion, so not all the fuel will burn. Explosive combustion is an explosion. It's a very rapid burning, not under any control. If an air-gas mixture is not ignited at the moment it begins to flow from a burner, a mixture of this gas and air may collect in the combustion chamber. When the mixture is ignited, it may explode. With proper design and adjustments, this can be avoided. Excess air is the extra air involved in the combustion process. Excess air is what's put in around the burners, and the combination of the excess air and the product of combustion makes up the flue gas. All these products must be vented. One of the common products of combustion is water. The water will stay a vapor as long as the flue gas is hot enough. Cooling the flue gas to condense out the water makes the furnace more efficient. You see this in the 90% plus furnaces. If the furnace is not designed to condensate the water vapor and the flue gas gets too low, the water will corrode the flue and cause the product's combustion to leak into the space. Condensation of the water begins at 180 to 200 degrees Fahrenheit.